Hi, my name is Gary. Today I'm going to explain about logic circuit using HDL. Before we go into HDL, what is logic circuit? Logic circuit is a circuit that performs logical operation on input signal. In this example, we have circuit containing two inputs, which are X and Y. These inputs go inside logic gates to produce an output which is symbolized as O. To implement this logic circuit, let's look at this house alarm logic circuit. How does the circuit work? The circuit will automatically trigger an alarm sound if any one or more of the windows are broken. Now this means there are two states of inputs. First, if the window is not broken, the input will be considered as 0 or low. On the other hand, if any of the window is broken, then the input will be considered as 1 or high. The alarm will produce sound if the output is 1. Since the output requires at least one high state input, we use OR gate for all the circuit. In our second slide, we see that there's a burglar who is trying to break through the window. As I said, one high state input is enough to produce a high state output since we are using OR gates for the entire circuit. Now that we have understood how the logic circuits work, let's move to HDL. A hardware description language, or HDL, is a specialized computer language used to program the structure, design, and operation of electronic circuits, and most commonly, digital logic circuits. HDL is divided into two types of language, VHDL and AHDL. For this demonstration, we are going to use VHDL to convert a circuit into a programmable code. This is an example of how we are going to turn the circuit into a source code. It's okay. We are only going to cover basic syntax for VHDL, including entity, architecture, process, and control structure, such as if, else, else if, case. Look at the example to see how to declare an entity. What is entity? An entity is a VHDL design unit. Every VHDL source code must have at least one entity inside. In this example, we declare an architecture called name. What is architecture? An architecture is declared to describe the internal design. One entity can have many architectures, but not the other way around. What is process? A process defines the logic operation of design. Process is like the internal of the architecture, which consists of lots and lots of logic operation. What are control structures? Control structures are used to direct and control the logic flow of a program. Type of control structures are if-else, else-if, and case. If-else. For example, Dini wants to go out and eat at a famous restaurant she loves, and she thinks about what she should bring to the restaurant. She will take an umbrella if it is raining, else she's going to leave the umbrella behind. Next, else if. Example, 3 boys are playing games. In this game, each player has his own rule. If he is a police, he has to catch the thief. Else, if he is a thief, he has to avoid being caught by the police. Else, he is a citizen and he doesn't have to catch nor avoid being caught. Next is case. Case is almost similar with else if. Here's the example. A student receives A grade when his score is 90 or above. He receives B grade when his score is above 79 and below 90. Finally, he receives C grade when his score is below 80. Add it all together, let's solve this logic problem. A car's danger indicator will turn on if one of these conditions is met. One of the door is closed, the car is ignited, and the seat belt is not used. Second, one of the door is not closed, the car is ignited, and the seat belt is not used. Third, one of the door is not closed, the car is ignited, and the seatbelt is used. That's all for theory section. Now I'll pass the VHDL language to Daniel. Thank you.
Hi, my name is Daniel, and I am going to explain about HDL programming. Now that we have understood the components of the syntax, we are going to apply it to create a circuit. The circuit that we are going to code is called the light indicator code. First of all, we have to create an entity. The entity that we are going to create is to determine all the inputs and the outputs we needed for the circuit. Let's call the entity indicator and let's name our inputs and output. For the inputs, let's name them door underscore closed, ignition, and seatbelt. Then we are going to type in bit and end it with a semicolon. In means the declared names that we typed previously are the inputs, and bit means that the input is in 1 bit. That means the answer can only be 1 high or 0 low. We are going to do the same thing for the output. Let's name it light indicator. But this time, instead of typing in bit, we type the opposite, which is out bit. Let's end our entity, and don't forget the semicolon. Now, let's move to architecture. The architecture is how the components are going to be assembled. Let's declare our architecture. It can be any name, but for now, let's just call it on_off architecture. Next, let's declare a signal, so that this value can be assigned to the light indicator output. Let's name the signal status and make the data type 1 bit. Inside an architecture, we always have the process of the architecture. This is where we begin applying the control structures. To start type process, and then load the inputs that we declared before by putting it inside the argument of the process. Use comma to separate the entity. Now type begin to start the process. Here, the question requires the light indicator to be on in the following. If the door is closed, the ignition is on and the seatbelt is not attached. If the door is open, the ignition is on and the seatbelt is not attached. If the door is open, the ignition is on but the seatbelt attached. Other than the requirements above, the light indicator will stay off. We can say that on means the value of status is 1 and the value for off status is 0. Therefore, the syntax will be here to remind you again. Don't forget to put semicolon in the end of each statement. Now, end the process and assign the status value to the light indicator to state the output. To end the code, end the architecture. That's it. We have our circuit interpreted into the VHDL language. I hope this simple tutorial helps. I am Daniel, and I'll see you guys soon.